Okay. So let's start about discussion this week. Uh, few of you or many of you have the question related to discussion. And let me share the screen. Let me start talking about. Can you see this? My screen. So if you see the screen, and in 2024, almost 44,000 employees are laid off. In 2023, it's about 260, and this is only tech industry, not other industries where you are working. So this trend is happening from last 3 years, and this website reports the data. So basically, my purpose is to give this assignment or to this discussion so that you can understand the regression and causes of causes of lay, laid off. So basically, this is happening maybe in your industry happening, or maybe your industry is hiring, whatever is the dependent variable. So let's say I'm making a model in my industry, which is like education industry, number of lays off, number of laid offs. So this is dependent variable equal to A is intercept plus Bx1 plus Cx2 plus dx3, and so on and so forth, and keep going, where x1 is student preference moving from, because in education industry nobody would like to wait for long time to get the degree, and they would like to go for Udemy or different other like 1 week course, $10 course. So one thing is lots of internet content or lots of internet material or internet short courses which helps them to learn in short period of time. So the bx second thing is cost effective. So first is internet courses. I'm not able to write because of my. The second is cost effective. Third thing, let's say third factor is maybe something other, that while working they can do that as as per their flexibility. So I would say flexibility and many such issues. Therefore, nowadays universities have less students. Not only one university, across the world all the universities are facing the challenges, and they are facing a big challenge related to cost. So what is their thing? They just reducing their employees because they don't have students, and these could be the reasons. So one, two, three. So let's say how I design this experiment in order to see. I go to one of my colleague in one university, let's say University X or University One, and I ask, what do you think in last 3 years, how many professor, how many employees are laid off? They say about 100. Okay. And then, so this is number of, then X1 on 1 to 7 point scale, I will ask, you know, do you think that internet is playing or internet courses or Udemy courses or short courses are playing uh, important role in reducing the number of students and all? And 1 to 7 point scale, let's say he gives 6. Similarly, he, cost, he says, yeah, it's much better. Flexibility, let's say he gives 6. Then I go to another my friend in different university, how many professors are laid off? He will say, no, we did not laid off. And he said, zero laid off. And he will give, his third university I will go and I will ask, okay, this, and I will collect some data. And based on that, I will run the regression and I will interpret and discuss. So basically, this is simple, a design of finding the reason and which reason is useful, which is not useful. We can make we can conclude based on the regression analysis. So this is my discussion of this week. Any question related to discussion?
Is
And
there a certain number of samples? Should we be doing like 30, 35?
yeah, so basically, if you know statistics, 31 is the thumb rule. There's a thumb rule, but I will, during the class, lecture, there's a minimum 10 predictors per. So basically, I will also suggest, I will talk about this. So if you get about 30, if you don't get, okay, just talk to few of your friends, based on that, you can, create some hypothetical data and you can talk. But if you get real opinion from real people, then you will get the real insight and you can think. But if you create some dummy numbers and something, then okay, that will be not significant, or but you can talk. This is another important, I can say this. So this is a video which is, I think, few days ago it came on YouTube, and I will share the link to everyone right here in the chat box. So you can watch. This is about 10 minutes and it gives a lot of insight about why things happening. Some people are saying in tech industry, they are putting more money for AI, they are putting more money for automation, more money for technology upgradation. Therefore, they are reducing headcounts because they need to divert the money from headcounts to technology and infrastructure or AI related things. So this is the reason. But I just leave you because healthcare. I see, many, healthcare is going through a lot of automation, and they have few doctors, few nurses. They ask you to just, give a call, online chatting, online thing, and they are just reducing their network and all. So in healthcare industry, this is also happening. I only understand one industry which needs more people is real, or construction business, because there is a demand of construction everywhere. And so this is the reason. So I just want to design this experiment and think and conclude, and this is the discussion. Is it making sense? So this is just 4 days ago this video came and I was watching. I thought to share with you. Now let's start with this week learning.
I'm still a little confused on the number of samples. So you said the standard's 31, but minimum 10. Is
Yeah,
that correct?
so if you really want to get good inferential statistics, at least 31 samples should be there. So degree of freedom would be, or for this case, you need to have more than 31 in order to. But model can be, just a minute. So let me show you one more thing. Okay, just a minute. And I think here, can you see my slides part?
Yes.
Okay, now look into this. How many predictors are needed? So this is a author or book author rule. NYK equal to or greater than 5. At least 5 observation per predictor. Here, at least 10 observation per predictor. And if you know the rule of thumb in statistics, higher the n value or higher the sample size, better is the result, better is the rationalization or generalization of your results. So, book says, I mean, this is 5 is too less. This is Evans rule. But, 30, I would say, because, whenever you do any real thing, 10 samples is very low. So I would always suggest, but I will not, deduct any point for that. And my purpose, you are able to design this experiment.
Thank
Okay.
you, that helps.
Yeah. Most welcome.
My other question was the Likert scale. I know you talked about the 1.7 point scale. Is that when we're asking that, are we asking that it's
Okay. So
that we
basically,
think it's 7 of like relative that specific point is
yeah. So
most relative, so that's number 7, etc.
yeah. So basically 1 to 7 point scale. Why I'm asking, because, okay, you can do 1, 2, 3, 3-point Likert scale. You can ask 1, 2, 3, 4, 5, 5 Likert points, 7 point, 9 point, it's all up to you. But, this is too few, because, you can have, so you need to get a, proper normal distribution. And, this is based on research. It is, observed that if you have 7, Likert scale point, it can have a good curve. So basically, that is the reason I'm asking 7. Otherwise, 5 is also okay. And if you want to go for 9, that's fine.
Okay, so it's like if the Likert scale is like 1 not relevant, 2 partial,
Yeah.
3, okay.
You can give the intensity. 1 is least and 7 is
7's most.
best. Yeah, yeah. So that you can do. Yeah, or
Great.
if you are going to find and you get something real data from internet or somewhere, you can use that as your data to do the regression model.
Great,
Okay.
thank you.
You're welcome. Now, let me start with. So this week we are going to talk about multiple regression. And before that, let me start with. So basically, most important thing here to understand the null and alternative hypothesis. When do we uh, accept null hypothesis? When do we reject the null hypothesis? So please understand what is the null and alternative hypothesis. All the true coefficients. So before even going there, let me start with whiteboard. So this is, let's say I'm going to start with simple regression. This is X, this is Y. And let's say this is a line, regression line. And let's say this is intercept, this distance. What is the slope? So this is for simple. I plot 2 points on the line. I draw perpendicular and vertical lines over there. So this is difference in Y divided by difference in X. Okay. And this is slope. So slope equal to difference in Y divided by difference in X. So this is slope and this is intercept. So basically I would say this is A or this is B. So how the equation will be? Y equal to A plus BX. Okay. You can understand the null hypothesis is all the true coefficient are 0, means this is 0 and this is 0. That means y equal to y equal to 0. So null hypothesis says all constants or all A, B or C in multiple regression you have many multiple slopes and one intercept. Okay, now what says alternative? At least one. So y equal to a plus bx. Let's say b is 0. This is 0. At least you have a value which is, so at least one of the coefficient is not 0. So how to, so this is very important thing. In other words, beta 1, beta 2, beta k equal to 0. At least one of the coefficient is non-zero, so that you can have y value. Otherwise, y value will be 0. So if you understand this, now let me start with my Minitab. You can do all these things exactly in Excel also. So first thing first, before going into regression, you need to understand, you need to get the correlation. You need to understand the correlation between. So I have some data about Indian students getting in US university. This is chance of admission, their GRE score, English score, university rating, statement of purpose, letter of recommendation, GPA. In India, it's a 10-point scale. It's a research or non-research university. So basically, this is dependent variable and rest are independent variable. So I'm just going to do statistics, basic statistics, and I'm going for correlation. And I just put all of them together, and I have the options, store correlation by default 90%. You can change the different level, and you can do the why I'm doing, because we can understand. So basically we got the correlation matrix. But it is difficult. Your eye, if you visualizing, your eye can blink or something, you can miss something. So this is the pairwise, which one is useful and which is not useful. So basically, if you remember the correlation hypothesis, so okay, I will. So Nasir, I will
You're trying to say,
explain your.
like, is it closer to 1 or closer to -1, right? To know if it's a positive or negative correlation. So if it's closer to 0, it's not useful. Is that kind of the idea?
Yeah, exactly.
Okay.
So let me. So basically, correlation is denoted by small r, and these are the values. Correlation is this, but this is for sample. What about the null hypothesis? Rho equal to this. Sorry, this is rho. I mean, okay, why my cursor is saying rho equal to 0. Null hypothesis saying alternate says rho not equal to 0. So look into this. Based on this, all p values are almost 0. That means if p value is more than alpha value, then we can say we fail to reject null hypothesis. But all the less than alpha value, then everything is this. This is not 0. So basically, you can see which is the highest correlation, and I think few questions are there, which is the highest, which is lowest, and you can also see which correlation is useful or useless. So all are useful. So basically, alternate hypothesis is here useful in simple word, and this is useless. Okay. So if this is clear, so this is first step. In simple regression, small r equal to small r into small r means correlation multiplied by correlation becomes regression. But here in multiple regression, it is not the case. So simple regression means one independent, one dependent, that's fine. Now let's go into the next step. So we check the correlation. Now we go to the regression. So statistics. Now we are just,
Professor,
yeah,
question on the correlation, is that the related to each other or is that the correlation related to the y-intercept?
so correlation is relationship between two variables.
And that's relationship between the predictors and not against the intercept, right?
Predictor, and you can, before going into regression, so let me, you can, so this is like X and Y. These are two variables. And when you see, what is the degree of this relationship, let's say, so this is, you can say based on this, R is like 0.95. So this is simple. There is a relationship, but this is not causal relationship. Means they are, you can interchange, you can put this by here, X here. This is 0.95 means 95. But if you look into the regression, you have to depend, this is, let's say X is independent. You have to define this is by is dependent. Then let's say, if this fit is coming like this, or, the fit, sorry, this drawing is, so let's say you just, in regression, let's say you plotted all, and the best fit line, this is X, and this is Y. So let's say this line is coming. So change in Y is due to change in X. This is called regression coefficient. Its value is from 0 to 1, where correlation is -1 to +1. Any value can be between this range. But regression is coefficient of determination. This is also called. It means this percent, let's say R square is coming 6 point, R square is coming 0.6. Okay. That means 60% change in X in Y is due to X. Means X is impacting by about 60%. And this is, you can say, simple relationship. Means you are a friend, let's say two entities, human entities, they are simply friend. But they are friend, you can have friend, but one friend is impacting others, that is causal relationship. If other friend is sad, this friend is also getting sad. If one friend is not sad or happy, he is also happy. So this is impact. Are you getting me? What is the difference between correlation and regression?
Yeah, I understand it. I was just wondering if you were showing this, the correlation is against the y-intercept or is it against the predictors? Because in the book, toward the end, they were showing the correlation against the predictors. So predictors to the predictors, just to be sure to test out for what is that called? The double, I forgot what the term is. Multilinearity.
Oh, multicollinearity. That I will
Yeah.
come later.
Yeah.
That I will come later.
Okay.
So
I just want to make sure this is just the correlation against the y.
Yeah. So
Okay, got it.
basically, multicollinearity we have to check, and that VIF is the variance inflation factor is there. So yeah, we are going to follow one by one.
Okay, sorry, I'm jumping ahead.
Okay, so yeah, so let's go. So this is correlation. Now let's go into regression. And we are, there are many regressions. So you can say here many regression. We are not going into all of them, and we can't do in 6 weeks course. However, we are just simply going into fit regression model, which is ordinary least square model. And now this is the window. And now here you response means dependent variable, and dependent chance of admission is dependent. Now, what are the independent variables? And all I'm just going to select under this categorical variable, you can select like research is our, sorry, research is our categorical variable, because here you have 0, 1, 2 categories. University rating is another categorical variable, but so it will make different models. So you can select those things if you have few things, but I'm selecting everything right here. Now here you have by default, you can select, I need to select one more thing, which is called residual, standardized residual. And okay. And I have to see Darwin-Watson test too. Okay.
So Professor, would the in the Likert scale that we're using, wouldn't that make every one of our variables categorical?
Okay, yeah. So basically, that's Likert scale. If you remember, you did BADM 503 course.
Did I know? I didn't.
Okay, so you didn't do the. So basically, if you remember from there, nominal, ordinal, interval, and ratio. These are the 4 scales, if you remember. And Likert scale is coming under this. We are not doing in this and this. So Likert scale 1 to 7, 1 to 9, 1 to 5, they are in interval ratio. So I think chapter number 3 or 2, I would request you to kindly, just review if you have not reviewed. So interval means 1 to 7, let's say 1 to 7 or 1, they are equally distance from each other. 1 to 100 point scale or 1 to 100. So basically this distance is meaningful. If you 1 to 3 or 1 to 5 in order category, the meaning is, I cannot define, okay, university rating 4, university rating 5. This is research university. What is the criteria of research university? What is the not criteria of research university? Non-research university. So basically here I can give the sign, okay, I can divide you into few categories, but I don't know what is the real difference among these categories. So basically, if you remember, or I would suggest you, those who have not gone through or those directly coming into this course, please review this scaling. And then you can, Likert scale is coming under interval. It's not categorical, it's an interval scale.
So you're saying that those would not be categorical predictors in the
No.
regression model?
No, actually in real life, those 1 to 7 point scale, 1 to those, they are interval scale and they are not categorical.
Gotcha. Thank you.
Yeah, I will, if you send me an email or, you have the book, all the chapters available for you. I think chapter number 2 or 3 is there, which covers this concept. And I would request you to kindly go through that. So, yeah. So if you look into this, so we did our regression chance of admission, and this is our model. And let me make little bit bigger so everyone can see. Okay, so yeah, here, okay, so basically, one more thing I would like to talk about those things. One thing is, okay, nominal, because I think I skipped that. I was focused on some ordinal. you asked the question interval and ratio. So if you remember, nominal are different name, different thing. Ordinal has the property of nominal, and they can be arranged in order. So basically ordinal has the property of nominal with, you can have order. Interval can have the property of nominal and ordinal, but it has meaning, the different meaning is the difference is meaningful. So interval, this scale has the importance. It can be, nominal, it can be different categories, but additional thing in Likert scale. So like you ask, it is categorical, but it has meaningful interval. Therefore, this is interval. Ratio has all the values, but it's a meaningful zero is there. So, for ratio, there's a meaningful zero. From there you measure. So basically, if you remember this scaling, ordinal has the properties of this, interval has the property of previous two, ratio has the all three, but little extra is adding. So like I said, uh, categorical, yeah, it is having categories. However, it has meaningful uh, and interval among those categories. Is it making sense? Hello?
Yep, I gotcha. Thank you.
Yeah, sorry, I skipped this point, because I was focused somewhere. And
So I have a question on that. So
Yeah.
if you were gonna go to that stat, the regression window, and instead of put everything in that continuous predictors section, you're gonna select out the categorical predictors. Is that gonna give you a different answer?
Yeah, so I can do that for you and you can see the result and then we can talk. So let's say I'm just going to select one thing, which is university. So separate model can be made here. So GRE to okay, so let me select this, and research and non-research, let me select here. Now you see this. So basically you make two models, one for research university, one for non-research university, because there are two categories. Similarly, if you select, university rating 5, there will be five uh, five uh, different model for level 1, level 2, level 3, level 4, level 5. So basically this is the difference. Okay, is your question answered? Because you have two categories.
Yeah, so I'm interested in let's say the coefficients and the variance, the inflation factor down below. Are they gonna be different numbers?
I didn't get your question. So what you
So
said?
if you scroll down in the coefficient section,
Yeah.
so that VIF there, the VIF number, coefficient, all those, since you are performing two different models, do they provide you two different numbers, I assume?
We are going to look into one by one everything.
Okay.
So let me go ahead, to explain one by one everything.
Okay,
Okay.
thank you.
Okay. So this is our, the result. This is the model. And look into this. So basically, this is intercept. This is, the slope for GRE. This is slope for TOEFL. And this is the complete equation that we got. So now we want to see whether, like our null hypothesis says, H0 all coefficients are 0. This is alternative says otherwise, at least one is not 0. This is our, so we can check our model one by one. Now, so this is null and alternative. I cannot scroll if okay, here. Okay. Now look into this. So basically we can start from here. The coefficient is minus 1.27, the p-value. So we are just going to check the p-value. So this is useful coefficient is this or intercept is useful in the model. And you know why? Because p-value is less than alpha value. By default, it is coming 90%, 95%. GRE score again is useful. English score, this TOEFL score is again useful because less than university rating. Now here you see that it is more than 5%, and therefore let's put this. Oh, sorry. Now statement of purpose. Let's do this. And this is again, so basically these two guys or these two variables are not or useless in the model. Means if you make a model, these two variables doesn't have any significant contribution in the model. So let's check, we will check about this. We will come, variance inflation factor later on. So first we are going to just talk about, and there's a relationship between these numbers. If you know this and if you know this, you can get this. So, if you, so what is the 1.276 divided by this, you get this. So I can show you through calculator. And here you can see 1.276. If you can see my calculator, 0.104. How much? Here you can get 12 point. So basically I did not put minus sign. It is about same. So basically this is the relationship p-value. We will talk VIF, variance inflation factor, later on. Now you understand which are the variables are useful in the. Now let's go into the next step, which is model summary. So this is S. This much result can be deviated from the prediction. This is R square, like we were talking about. R square can be 0 to 1. Here they have written in terms of percent. So how I can say in terms of wording, 82.19% chance of admission depends on GRE, TOEFL, university rating, SOP, LOR, all these variables. So 82% chance of admission can be affected by GRE, TOEFL all together, all 5-6 variables. So this is R square, means this is. Now let's come to the R square and adjusted. What is this R square adjusted? This is always little bit less than R square. That means this is 82.19, this is 81 point, which is small, because you can say this is more filtered value of R square. So basically, you know, some useless items are removed, some, you know, so this is more filtered item, and this is always lesser than, you know, this value. So basically, you know, in reality, this is used. Some people also use this. I haven't seen this in much practice. So why this? Because, you know, you remove all unnecessary data or something. So this is only purified or more filtered result. Now let's come to the next step.
Hey, Raj, I had a quick question on that.
Yeah.
On the R squared, the other variable, can you just give a little more, like a real life example why you use that? Just over the R squared.
I mean,
Because
to
why
be
it's low
honest,
lower.
I could not hear you properly. I
Can you
mean,
hear me now?
my
Is
microphone.
that better?
Yeah, now please let me make my sound little bit. Okay, now please tell me.
Are you able to provide a real life example of when you actually use the R square adjusted?
Yeah, so
Or,
yeah, I'm just going to show you.
okay.
So here you see this is this is R square and R square adjusted. So look into this. This is regression. Whether our or complete regression is valuable or valid or not, entire regression, you know, that you can see using this p-value again. Because the reason is that, again, regression is useless and regression is useful. The null hypothesis, R is alternative hypothesis, p-value is less than 5%, and we can say entire regression. So when the question is asking whether your regression model is valid or not, you have to use this line. You have to see this line and this value. And, you know, other things are exactly same now. So this is based on ANOVA. Now let's go into the, so you can understand whether. Now you can see in this 500 data set, in 500 data set, these observations are not, you know, these are out of, you know, fit or out of, so basically unusual observation or something, unusual observation in the data set. Number 10, chance of admission is 45%. And so basically out of 500, maybe I error that somebody when entering the data, somebody recording the data. So you just go and check whether these data values or these data points are correct or not. So basically this is unusual observation. So basically this are, you know, two variables are not useful in this model. These are things. So basically, if you filter out the R square adjusted like you are asking, this has more filtered value. So in reporting, always they put, you know, R square and R square adjusted, which is more filtered, more removing unusual or unwanted noises in the data, and therefore this is little bit less.
Perfect. Thank you.
So,
That makes sense.
and this, you know, this, to be honest, I have not seen in, you know, in my academic life that somebody is using R square PRED. So you know, I can't tell about this thing, but it is more filtered. So this is a regression. Now we come to the multicollinearity. We come about different aspect of regression. Now, multicollinearity is big issue in the data. And nowadays, why? Let's say, you know, you are doing two thing, and online, let's say online courses, and then cost effective courses, cost effective. These are the two variables. And if you take the responses from the pupil and 1 to 7 point scale, they say, yeah, this is online courses 6. And here they also give the 6. And when you ask many things, this is high collinearity, means the values of the variable is almost same. And similarly, so this is, so basically when you lays off, when you do the lays off, they will put the almost exactly same impact on the lays off, because their value, they are almost similar in the relationship. Therefore, we look into the relationship, and based on that, we come to the, so to avoid, to check the multicollinearity, we check the VIF factor. And there, now your question is here. So VIF factor, here, these are the things. So basically, this is under limit. Now, for checking that, you go under this correlation among variables. So look into that, where you see the very high correlation. Do you see 9.9 something? And, I don't see similar relationship among very high correlations between 2, 3, which is 0.9, 0.9, which is almost same behavior. And I don't see almost same. So here, so now we come to the multicollinearity. Basically, yeah, here occurs when independent variable like x1, x2 are intercorrelated instead of being independent, means high correlated. Let's say, like I said, online courses, cost effective courses, they are highly intercorrelated because online, those courses are in masses, very, therefore $10, $20, $5, this kind of, so collinearity occurs if only two predictors are correlated. So multicollinearity. And now we can clearly understand this. You can see this is 0.9, 0.99. And therefore we see this is highly multicollinear because they are almost same. 100% is almost same. So you can see here. But what is the rule here? You can check using VIF. What should be the ideal VIF? And here is the table. So basically, you can clearly see when it is 1, no, excuse me, no variance separation. It is up to 2, mild, 10 strong, and 100 is severe. So basically, and if you see some researches, some academic research, which I usually see, people report up to 6, 7, 8, and they don't see any problem up to 6, 7, 8 level. And there are now, debate in Statistics Society and different other research forums that multicollinearity or VIF is irrelevant in the research. So, okay, so basically our data, which we see here, we have, where's our data? So you can see we don't have any strong or severe. We have our VIF about 4.46 is the highest, 4.7, less than 5 is the highest. So basically we don't have a strong or severe multicollinearity in the data. However, if you see, if you see more than 10, then you have to look into the variable. You have to see if you have to observe and you have to treat that. Means why they are coming, and you have to deal with this. But here it is all under control. Is your question answered? I don't remember who was asking because I was not looking about this.
Oh, Raj, this is Gavin. Yeah, no, that makes sense. So basically, ideally you'd want a lower VIF to keep
Yeah.
so the yeah.
You know, there was a female voice who was talking about this.
Yeah, that was me. Yep, you answered my question. Thank you.
You're welcome. Thank. So I can't see, you know, who is talking, just I can listen. So where am I? So this is multi. Now there are some other questions related to this. There are other. So basically, what is error? So let me draw this. Let's say this is fit line. And let's say this is the difference between fit line and actual. So this is plus difference. This is minus difference. So these are error terms. Now there's a thing whether error are normally distributed or not. So basically we have to see that whether these errors are normally distributed or not. So we go under this other things that, you know, on the top to check everything whether okay. Here under graph, and we have probability plot. And here you can see, and I'm just going to use residue. Oh, sorry. And now scale and distribution by default, it is coming. So I just do this. And now you can see. So this is, you know, normal distribution at 95%. And now p-value is less than 0.005. That means so basically here you can see, sorry. Test for normality. So sometimes the effect of predictor is non-linear, and here you can see test for normality. And here, and the null hypothesis says it's normal, and alternative says it's not normal. Where's, sorry, I just, you know, I made a PDF which I forget to show you. Okay, so this is the PDF that you can find at the end of the module, and this is the way to proceed. So everything is right here. So I think I already spoke about all these. So here, this H0 is normal versus H1 is not normal. So here you can see if you get everything, p-value is more than, then you can say it is normally distributed. But in our case, when we looked into, it is not normally distributed. You can also see, you know, some numbers are coming here in our Minitab outcome. So what we can say, p-value is less than, that means not normally distributed. So you can see this is going out of the way. So remember the null and alternative hypothesis accordingly you can make based on p-value. So here you can see this data, this says it's normally distributed because almost everything except 1 point is coming within the range, within the normal distribution range. So this is normal, but in our this data, the errors are not normally distributed. So this is
So would you say anything that all of those data, if it falls within that range, those lines, those 3 lines there, would you say is normal without looking at the p-value?
so basically p-value is very important because in naked eye, this is the this is 95%. So this is, if everything is almost here, then you can say it's normal. But if anything is going out of this, or mass is going, or many points are going out of this, so basically this is not normal. At 5%, let's say maybe 20%, it may be normal, but not at 5%. So you can, some researchers, they change the confidence level from 95 to 90, and they try to see at what level it is normal and it is not normal. So some change this. So this is one thing. P-value, intercept, and yeah, another important thing. So like you were asking about the number of responses. So I think I already covered, but statistics rule of thumb, as many as sample size, higher the sample size, better is the result. Or you can generalize. So and let's say this is normality, and now we come to the Darwin-Watson. I would like to share the Darwin-Watson. We already spoke about multicollinearity. So here, so we already checked this homosadistic and heterosadistic. So basically, if you see this kind of behavior, funnel in or funnel out, this is heterosadistic. And if you see then homosadistic. So basically, this is not in our exam, but our errors are autocorrelated. This is another thing. Errors are non-autocorrelated, errors are autocorrelated. So this is another thing, and it can be explained by Darwin-Watson test. And this is very simple. If Darwin-Watson is less than 2, positive autocorrelation, and Darwin-Watson is more than 2, is negative autocorrelation. That means, and this is useful only, and time series data. So we don't have time series data here. And this is unusual observation, which is not fitting into this. We already covered those unusual observation because maybe error, maybe response behavior, maybe something that is giving unusual behavior. So Darwin-Watson is useful in ignore Darwin-Watson test for cross section data, and this is our cross section data. But it is because when you take the time series data, this is useful because sometimes due to time and they are autocorrelated, some variables. And look into our data. So we checked somewhere Darwin-Watson test. Now after that we have few more points. So which is coming less than, this is about this, but we can ignore because this is not time series data. This is cross section. Now another thing that I would like to show you, that these two variables are useless in our model. Which one is university rating, and what is the second thing? What is the second thing? Let me see. P-value, university rating is an statement of purpose. These two are irrelevant. So let's see how it works. And we can, so what is the R square is 82% when we include both of them. Now let's do this statistics, regression, and predict. So basically this predict option will come only when you run the regression model. When you run the regression model, only then this option will come. Otherwise, this option will be disabled. So first, we have to run the regression model because I think last regression model was different. So let me run the fresh regression model. So I'm using all of them together. So GRE2 research. Okay, let's go. Okay, so now our machine or our Minitab remembers the last action. So this is the last model. Now let me go into predicts. So basic stat regression, and predict. Now here you go and chance of admission. And here you have the values to predict. So let's say GRE score, I'm just putting 312. I'm taking two numbers, I'm predicting for two things. TOEFL score, I'm just 110. University rating, let's say I'm putting highest degree and another I'm putting least degree. Statement purpose, again 5, and here, and letter of recommendation, let's say I'm putting 4 at both places. GPA 9, and research both, let's say I'm putting research. Now let's see what is the result. So first stage, this is where I put, both useless variable highest, university rating, statement of purpose. What is my fit value? Use 80%. So this is 80%. When I put both values lowest, what is my fit value? 77.5%. That means if I don't give, university, I don't submit a statement of purpose, I don't select the rating, my chance of admission will be only 2.5% will be less. Means if I miss, or about 2.5% less. That means this is not playing any important role in the model. Because if you have highest maximum, if you on your letter you get 5 out of 5 and you get 1 out of 5, it is only 2.5. So you can see here you don't need to put the energy. Other important things are there. So basically, this is how to predict. There are some questions based on prediction. So here you go regression, predict, you put the value and you can get the number. So is it clear to everyone? Other way you can also do under assistance regression, and you can get here the options, multiple regression, and you can response chance of admission, but here up to 5 variables. You can't add more than 5 variables. So this is a limitation. You can add some categorical. So you can get all those things here also. So let me do the chance of admission here, and let me do 5 of them here. 1, 2, university rating. So let me remove the 2 use. And here you can see R square is 82%. If you remove those useless things, still R square is this. And you can read, so heterosydetic or homosydetic, this is looking like a funnel. So here you can see equal variance, unequal, and it can give you a lot of insight. So this is another way of looking into regression. Now, please feel free to ask question if you have any.
Are you gonna cover the nonlinear regression?
No, we are not going to cover in this. We are just going to, there are many regression thing. So in our exam, we are just covering this simple thing, which is fit regression model. And we have, logistic regression, other regression, those, we are not covering in this.
What about the multiplicative models or something like that?
No, we are not.
Multiplicative.
So we are only covering ordinary least square method.
Okay.
So this is only actually I can cover, and we can have, but we have students from different level, and some have some experience. So we are just keeping it simple. Those who are really interested in regression, they can learn automatically, after this foundation. So, but we have a plan to launch full-fledged, business analytics courses for MBA that will include machine learning, random forest, everything. But this subject requires a lot of work. It is not easy that if I put all of them. To be honest, it's very challenging.
Yep, I hear ya. Can you go over the non-variance, the non-constant variance, the hetero rule? I cannot say that term. I'm sorry, those charts, yeah. Can you show us one more time on how you get to that, or do you need to get to that assistant button to get to this?
So basically, this
graph?
chart I go under assistance.
Do you have another way to go to get to this?
Yeah. So basically, this is you can see this is basically residual versus fitted values. So here you can get residual versus, it is challenging from there, but I always prefer you can go directly from once you run. So here, this is the best way you can get here. So yeah, because this is funneling in or funneling out. So this is called unequal variation in the data. So yeah, this is the way you can, it's a simple, easy to check and understand.
Hey, Raj, question for you on heteronormal. Is there a number way aside from just visually looking at the graph to tell?
I'm sorry, again, I could not hear you properly. Let me remove my microphone. Yeah, yes, sir, please tell me.
Other than visually seeing it on the graph, either to tell it's hetero or homo.
Yeah, actually, we can only, we can visualize here. You can see the, you can see this non-constant variation. And here you can see the hypothesis. And so basically you can see, can be visually tested by
Okay, it's only by visually.
Yeah.
Graph. Okay, that's all I wanted.
Any other question?
I have another question. So in regards to our.
Yeah, please.
So in regards to our. So taking this data and running using LaTeX and running the data for that. Do we have to use all that data? Is that correct?
To be honest,
model?
maybe, hearing is, can you type the question in the chat box so I can properly hear? I mean, I can understand.
I'll try to talk slower. For the discussion.
Yeah.
Are we using only the data that you have given us inside the module.
Yes, yes. Yes, you know, in the fill in the blanks and all, only the data which is available in the there you can use that. Nasir, I would like to answer your question if you know. So to be honest, can you type your question so I can understand properly? Because hearing, I mean, your voice is coming, going, is not properly. I can hear you. In between, it is breaking also for me.
Understood. I'll type it.
I have a question too while Gavin types his question in.
Yeah.
So when we see the fan out, fan in
Uh,
pattern and it's pretty obvious, for example, what do we conclude? Because let's say p-value tells us that it's useful, but then we see this pattern.
okay.
So
So
in real life, what would you do?
no, real life, you know, this is, you know, you can only plot, you know, this is, you know, non-constant variation. This is will also visually test for normality. So basically you can see the normality test for individual variable, but here this is heterosyncretic and homosyncretic situation where, so individual variable like residual versus, so this case is residual versus fit. Are you getting me?
So, like this last sentence here on the PowerPoint, violation of the constant variance assumption is potentially serious. It was like the point in I think in the slide. Yeah, this one is potentially serious. So does that mean if you notice fan in or fan out, then
Yeah, you know, if
maybe
it
you
is
can't
like,
use?
yeah, basically we need to look back, you know, if you see any such issues, we need to look back and check our you know, data from the data. Like if you see, you know, unusual observation 50 you have 500 data points, and if you check like 150 are unusual, so basically we need to go back and look into the data where we are making, you know, some data is the issue. Basically from their data cleaning, you know, different subject related things, you know, you need to clean the data, and there's a separate course for that, there is separate topic for that. But you know, for if you have good clean data and you know everything, then you will have ideal results, good results. But if data, you know, the regression model only you can validate when you see everything is perfect, then only you can predict something. But if you see, you know, some violations are coming, then you have to clean the data and then rerun, and then, so these extra tests are for real life situations where you can check these check these different uh, uh, you know, diagnostics before making any prediction, where we really validate from every point of view to do real prediction. However, we are just limited to learn this. So in exam and, you know, in this, you will come only up to prediction. You will come up to validate this model. So basically, I'm not keeping multicollinearity. I'm not keeping the normality. I'm not keeping this heterosyncretic or homosyncretic. I'm not keeping also Darwin-Watson. So basically all these extra things after, you know, after model validation, I have not included in exam or included in the fill in the blanks or assignment.
So
Okay.
ultimately, we are trying to look for the what's that called? The constant variance.
Yes.
If you, so
We are-
it's we are trying to accept the null hypothesis is what that goal is.
So, you know, basically, oh, where is the the null hypothesis says here, where's null errors have constant variation. So basically we are not interested in this. We are interested in this.
Okay. Got it.
Yeah, Gavin, now I understand. Sorry, for a long time. Now I understand you are going to make your own data, or you are going to collect your own data, or you are going to get your own data from secondary sources. So basically, you are going to analyze that data to discuss, I'm not providing any data. So this is like a designing your own experiment in discussion, and based, based on the data, you are coming to the conclusion. Is it making sense, Gavin?
Yeah, that makes sense. I just wanted
Yeah.
to make sure that, I have to go find the data from.
Yeah, or
secondary sources.
if you don't get anything, then you can just randomly create. Now I
Yeah.
would Nasir, your question is there 10-point skill. So Nasir, are you there? Nasir, sorry. Nasir is not here. Nasir, usually if you are not there, I'm looking your 10-point scale. Yeah, usually people go to 9 and they also go up to 11. And then Ron is asking, Ron, did I answer your question?
Yes, you did.
Okay.
It was just a statement.
Okay, thank you.
Thank you.
Yeah, because I was not looking the chat and I don't know whether I remember to answer all the questions or not. Okay, thank you. Have a wonderful evening
You're welcome.
and wonderful night.
You
And
too. Thank you.
Hey, Raj,
Thank you.
Most
I have
Thank you.
Bye.
Thank you.
Raj, I have
Bye.
one
Good night.
question.
Oh, go ahead.
So for the data, if we can't find it, we just make it up our own data.
Yeah, you can
Right.
random, you can random generate in Excel, or you can random generate in Minitab also.
Mhm. And then you want at least 30, right?
To be honest, if you are having real data or something, you are able to get data secondary sources, whatever you get. But if you are generating, you generate 10 or you generate 30, doesn't matter,
Got it.
Yeah.
I
Okay.
did have a question too, Professor. If we, how do we read the ANOVA table to know how many predictors there are?
So basically, first you need to, in discussion, I said, you must make the hypothetical model that, okay, number of layers depend on following factor. Let's say you find 4, you find 5. You have to discuss. So 3, 4, 5, it's, not hard and fast. But if from your logic, you understand 5 important factors are playing most important role in layers of, okay, you have 5 predictors. If you say no, maybe 3 are sufficient. Multiple means more than 1, but don't limit to 2, you find more. Is it making sense? So first you need to.
It does. I just don't know how to read it from the table. Is it just the degrees of freedom?
It's the degrees of freedom for regression, I think.
Okay.
The number, the K is the number of predictors.
Yeah.
Okay. Thank you.
You're welcome. Okay. Have a good night. Bye-bye. See you next week, next Tuesday.
Thank you.
Welcome.
Thank you.